So I needed a way to discharge the 12S modules once they're full. The modules that I sell, I will basically charge them up to 3.9 volts and then balance them at that voltage so that they're balanced when the cells are charged. Then though, I have to discharge them down to a much lower state of charge so I can legally ship them. The limit is about 30%. So I'm going to be charging them up to 3.9 volts, which is about 75%, and then I'm going to have to basically cut off 45% to get them down to that legal safe shipping limit. And that'll also let me test the actual capacity of each cell. So basically I'll know, okay, I've pulled 30 amp hours out of this cell, so they should all be at this voltage X or whatever. And if that's not the case, then something's wrong. So I needed something to discharge it. So to charge it, I'm just using this Lambda Gen that I just got specifically for this purpose. Someone was selling like, I don't know, 5 or 6 of them online for just maybe $400 a piece, working, brand new, I guess. They don't look like they've ever been used. Anywho, so this is the charger, and this is a 60 volt, 55 amp, and I'm going to be charging the batteries up to 46.8 volts, and so I'll do that at 55 amps, so I'll be able to charge, in the high 2 kilowatt range there to get these batteries charged. These batteries are 2 kilowatt hours, so it's going to take about an hour, maybe half an hour to charge them, just depending on where they're at right now. And then, yeah, once they're charged, we'll do balancing, which is over here, which is going to be this old LIBCM PCB, and then some real high power discharge resistors, and some much higher current FETs, and probably a custom fan or two there as well. And then once the cells are balanced, then I need to discharge it, and that's where this comes in. I was going to make this, and I was starting to look at buying all the parts for it, and then I realized a dryer element. This is a replacement dryer element for, like, I don't know, a Maytag or whatever, and it was like 26 bucks shipped. It's crazy. This thing is designed to do 20 amps at 240 volts, and right now I have it doing an equivalent of about 15 amps at 240 volts, so we're using it well within the range. That's a 3600 watt discharge, and to simulate that right now, just to make sure my math works, this is designed to work with 240 volts AC, so I had to take some real high temperature. This is Teflon wire with the fiberglass coating. It's rated to very high temperature. I don't actually remember what the temperature is, but I used it in the reflow oven, and it's actually inside the oven, and it works just fine. That gets pretty hot. So this gets hot too, and I wanted to show that to you. I did have to get out a second Lambda Gen because this first one can't drive this one all the way. My calculation was that this should pull 78 amps, and we ended up pulling actually 78 amps. Great when the math works. So here that is. There's this first and second unit here, and together they're doing the correct output current. This is the actual voltage of the battery, which would be starting at 46.8 volts, and then of course the more it got discharged, the more the voltage would fall. But you can see this getting a little warm, and you don't actually even need the thermal imager because they actually start to throw off photons as the orbital state drops back down because they're really hot. But anyway, yeah, this is looking around. I actually don't know what this thermal imager is rated to, but 330C, that seems within the limits. So this will be, at least while it's hot outside, this will be on the front porch. And then once it cools down, I'll just put this inside. Of course, I will fuse it. It'll be a little nicer. Again, this is discharging these batteries after they've been balanced. So that's what this is doing. Right now, I've just got this ghetto fan on there. You can see that the fan does not cool well. The airflow is not fast enough to fully cool these coils. I actually think that because the fan right here is not blowing air, that's why we're getting this localized hot spot there. You don't actually get that on the bottom, which was surprising to me. I figured it would be more confined, but maybe the air is more contained and therefore can blow more. Yeah, in fact, when I put my hand there, gosh, it's hot, but I'm gonna grab some cardboard real quick, some test cardboard. See if we can actually get this to cool down here, if we can focus this air. It's warm. Not really, but anyway, there will be a better fan. Actually, maybe it did. There will be a better fan solution. Just haven't dreamed it up yet. So anyway, yeah, we're still rocking and rolling. It seems like we've come down a little. We're at 46.1. there's some voltage drop issues here just in this test case here. So that's 78 amps. So yeah, that's what we're trying to do. And we are at 46.4 volts. The goal was 46.8. That's close enough. Anyway, yeah, these are supposed to glow. I'm actually using this way below the limit. This is about 3,600 watts right now, which again was about 15 amps at 240, whereas this was designed for closer to 20 amps. Anywho, need a better fan solution, but otherwise that's it. And right now this is hot. I can definitely feel the heat coming off of that, and I'm sure it will ruin anything downstream of it. So we're going to go ahead and stop that. Yeah, anywho, that is the 47 amp hour FoMoCo cell tester. Yeah, as always, thanks for watching.